Is this app about? This app is about South African dams that are basically classified into three levels of hazard: low, significant, and high. These dams are characterized by multiple parameters, and these parameters in turn assume multiple values. So, prediction of dam hazard is an extremely complicated task and requires complex non-linear decision makings. In this Under this scenario, what we provide is an artificial intelligence based expert system to visualize and accurately predict the hazard level of South African dams. And how can we help in the process? Firstly, the app is interactive in nature. So for each time that you input the various values of the dam parameters, the app will instantaneously give you the hazard level. Second, the app reduces the cost of survey. So whether the app user uses it from the comfort of the office or from the field study, it can be accessed provided that they have internet on their mobile phones, tablets, or computers. Third, it reduces the dependence on skilled surveyors. And fourthly, we provide multiple visualizations to understand the state of the dam, the geographical locations, etc. And lastly, the algorithm that we use in the creation of this expert system is extremely robust and can handle outliers and wrongly imputed values. And for the last part of it, that how good is the prediction accuracy of our algorithm and the expert system, we have achieved a very high level of overall accuracy of above 93%. Now, let me take you to the software architecture of this expert system. So, what you see on the left are these three program files that will eventually get uploaded in the cloud platform. And once it gets uploaded, so anyone at the field of survey can access the app, and once they input the data, it gets processed in the server, and instantaneously the surveyor can get in the results. Also, at the same time, for someone who is sitting in the office and having internet access, they can use it on their computers or laptops. Now let me take you to the various facets of this app. The first is the view of the raw data, or the data that we have got from the South African Water and Sanitation Department. Let me show you the first couple of rows of this data. So this is the basic data or the raw data, and as you can see, there is a lot of columns of variables that are used to classify each of these stamps. Now, let me show you one complication with this data. So let's take up a dam called Boomerang Dam. And as you can see, what we have over here, the data got sorted according to the Boomerang Dam records. And what you can see over here, that for the same dam, we would have three levels of hazard. So first one, it is predicted as significant, and for the other two records, a Boomerang Dam has a low level of hazard level. So this is the complication that we have in the data. And as we go further, we'll use certain algorithms that are able to avoid these kind of complications and give very good results. In the meantime, let me also show you the volume or the dimensionality of the data. What we'll be working with is that the number of rows of data that you'll be working is 5,226. The number of columns right now is 40, and the number of dams that we'll be working is 4,843. Next, let us look at certain visualizations of this historic data. So in the historic data, what you first see is the data that is statistically significant. We have carefully selected these variables and reduced the initial variables to these carefully selected bunch of variables that are statistically significant. We have also done missing value imputation and to get further good results out of this data. So what you see over here is the statistical variables. So you can have a long list of them, and these are interactive in nature. So in case you want to find out say for example, for what were the dams that were completed in 1943. You can see that the data got sorted, and you can use this kind of filtering to view a large number of characteristics of these dams. So that being said and done, the next thing that we look is into the characteristics of the dams. So these figures actually show you that what are the overall characteristics of the dam. So let's look at a figure on the left. So it gives the relative frequency of the dam level. So the largest number of dams, just above 60%, are of low hazard. Next is the significant, and the high is the lowest. So all these values would add up to 100, and so that's the reason that we have, for easy understanding, we have put it the relative frequency in percentage that ranges from 0 to 100%. So similar kind of figures we have on the right, where we show the relative frequency of sizes of the overall dams, and then in the extreme right figure, what you see over here is for each of these sizes, what is the hazard potential. So for dams, the smaller number of dams, we see that they have a high level of low hazard potential. So next, let us look at the geography, overall geography. This actually shows you that for in which provinces, what would be the relative frequency of dams. So that you can see over here, Western Cape has the largest number of dams, and the figure towards the right also shows you that Western Cape would have the largest number of dams, and in it we see that the significant number of dams is, or significant number of hazardous dams is approximately 50%. So this would give you an overall idea of what are the dam statuses in each of the provinces from a geographical perspective. And next, let us look at the comparison of hazards across years. So on the x-axis, as you graduate from the previous years to the current years, you see that the hazard level have actually remained fairly constant for the significant dams, and then for the lower level of hazards have more or less fluctuated. So this is in terms of years versus geography and time. And let's next look at the historical data, the model testing. So this is the part at which we show you that what is the complexity involved in the decision making process, and how accurate is the machine learning algorithm that is used in building this artificial intelligence based expert system. Let me first show you the complexity of the decision making process. So as you can see this pretty complicated graph over here, what it shows is for each of the hazard levels of high, low, and significant, that takes up three distinct colors over here. And for all of these colors, the more the overlap that you see over here, the more is the complex decision making process. That means that you cannot have a linear logic to separate the the less hazardous dams from the significant ones or the high ones. So there is no linear relationship by which you can say that with a certain specific values of the parameters, you would have a linear combination of the hazard level. So this being said and done, the next thing I would like to show you is how accurate is our prediction. So what you will be doing eventually in the next tab is that we will be inputting values of the important parameters, and the algorithm will push out the result that whether the dam would be of significant hazard, less hazard, and high hazard. Let me show you the accuracy of the prediction. So what you can see towards and the extreme right is the first model building is taking place. So it will take a couple of seconds. Now let me show you the results. So what we have over here is our training set has 2,839 data points, and our test set has 1,217 data points. The accuracy that we receive on our testing data is 94.82%. That is a very high level of accuracy, meaning that for every 100 inputs that you send into the algorithm, for 94.82 cases, you will be having absolutely correct outputs. And the number of seconds that we have taken in processing is 10.6 seconds. So that is the accuracy, overall accuracy of our algorithm. Next, let me show you that what happens in the final tab, that is the final prediction based on user inputs. In this part, what we are trying to show you is that if an user, suppose a surveyor on the field, gives in certain inputs, uh, the app will automatically be throwing out the output. So let us see what the output looks like. So for this tab on the right side, you would have a slider input over here. So you can see there are 15 slider inputs for which you can choose the various values of the parameters. And depending upon the parameter value, the app will in fact show you the uh, most appropriate result of the hazard level of a dam. Let me change two parameters over here. Say, for example, I want to change my water management area from 5 to 6 over here, and the arch type I want to send to do it buttress. So let us see what the changes has happened and how the results have come up for us. Let's wait for a couple of seconds. There is a process being utilized right now. The algorithm is running and will throw us the best result. So we have approximately seen that for 5,000 data records, we took take more than 10 seconds, approximately 13 seconds, 13.74 seconds over here. So let me show you how the results have occurred. So we have changed the water management area from 5 to 6. So that has got changed over here. And we have changed the wall type to buttress. So taking all of these values towards your left, what the algorithm has predicted for you is that the probability prediction of hazard level of a dam with the above chosen inputs, these are the above chosen inputs are, and for so it would have a probability of high as 40%, low as 41%, and significant as 19%. So taking in the highest probability value, we would be choosing the highest. The hazard level of the chosen inputs is low, so that is being showed because the low has the highest probability value, as you can see over here. And added to that, the time taken for the prediction is 13.749 seconds approximately. So this is what we provide as an expert system to analyze and predict South African dams hazard level. The best feature about this application is that it is highly interactive, and when put into the server, the app will actually talk to the user and instantaneously throw output on a HTTP address, because this app will actually be hosted on a web server, and anyone who has an access to the HTTP address would be eventually be able to use it irrespective of where the person is. Uh, just an internet connection would be fair enough to get in the best results. Added to that, the algorithm has been developed such a way that it is extremely scalable in nature, so that when you have more rows of data, or the volume of the data increases, even then the results that you will be getting are will be fairly fast. So this is all that I had to say in terms of explaining you what this expert system would consist of. In case you have any other queries, please feel free to reach me out at this email ID that I have provided over here. And thank you for your time. I would love to hear from you. Thanks again. Bye.